So this question of kinematics, it says that a particle moves in a straight line so that t seconds after leaving a fixed point O. After leaving a fixed point O means it is leaving O. Okay, so after leaving a fixed point O, its velocity v meter per second is given by this equation. So find the acceleration. Acceleration is is rate of change of velocity, dv over dt, when the velocity is 8, and this value you will use to get the value of t. So let's quickly do it. So as a is equal to dv over dt, so it means that you will take derivative of 10 into 1 minus e power minus 1 over 2t. Now 10 will move outside and it will become 10 and then d over dt of 1 minus e power minus 1 over 2t. Okay, so 10 d over dt of 1 minus d over dt of e power minus 1 over 2t. As you know, this will turn to 0 because the derivative of the constant is always equal to 0. And now you will take derivative of this. Derivative of the exponential function is always same function, minus 1 over 2t, and then we take the derivative of the exponent. Exponent is minus 1 over 2t. So when you will take the derivative of exponent, you will get 1 over minus 1 over 2, and that 1 over 2 will cancel this term, and it will turn to minus 5 e power minus 1 over 2 t. This minus will go outside. This is the expression for acceleration. Now let's find the value of t when v is equal to 8. So when v is equal to 8, then we will write it as, when v is equal to 8, we will have it like this: 10 into 1 minus e power minus 1 over 2t is equal to 8. This 10 will move on other side, it will become 1 minus e power minus 1 over 2t equals to 0.8, and then it will become 0.8 minus 1 and e power minus 1 over 2t, and you will get here minus 0.2 and minus e power minus 1 over 2t. This cancels this one, so e power minus 1 over 2 power minus 1 over 2t is equal to 0.2. so now this e power minus 1 over t will substitute its value, that is 0.2. so when you will substitute it here, because this is a, so this will implies to a is equal to 5 minus 5 into minus 5 into sorry, I missed this minus sign here. So this will be positive because this minus and this minus will turn to positive. So minus no, this is positive. So positive 5 is equal to 0. Positive 5 into 0.2, that is equal to 1.0 meter per second square. That's the answer of the first part. Now the second part is calculate to the nearest meters the displacement. Displacement is it's the integration of velocity. Fine. So from O to 6, so from 0 to 6. These are the limits. So let's find the value of the displacement. So obviously we will integrate right here. S is equal to integrate the function of integrate the v, that is equal to 0 to 6, and it is 10 into 1 minus e power minus 1 over 2t dt. Use the brackets carefully, and now take out 10 and split the function like this, 0 to 6, 1 dt, and then minus 10 into 0 to 6 e power minus 1 over 2 t dt. So when you will, the integration of the constant is always the variable, so it will be t into 0 to 6, and this is minus 10, and it will be, the integration of the exponential function is always same, so e power minus 1 over 2t, and when you will take a derivative of this, it will be minus 1 over 2, and with that factor you will divide. Maybe you know the rule of integration of exponential functions. So it will be from 0 to 6. Now from here I solve it here up. So it will be now when we'll say figure it out, this factor, so it will be 10 into upper limit minus lower limit minus 6, so it will be 10 6 are 60, so I'm going to write here 60 minus this minus will cancel this minus and it will turn positive, and this 2 will multiply by 10, so it will become 20, and this we will write as it is e power minus 1 over t. Limits are from 0 to 6. Now let's figure it out quickly. 60 plus 2 plus 20, and this will be e power, when we will apply 6 it will become minus 3, and when you will apply 0 it will become e power 0. So e power 0 is 1, so it is 60 plus 20 into e power minus 3 minus 1. Now this you can figure out on calculator, so I'm going to use the calculator to get the exact value. So this is basically this is 60 plus 20, use alpha 20 bracket alpha, then press times by 10x, this will be giving you e, and then power minus 3, and then minus 1, bracket closed, and this will give you 40.995, and to the nearest meters it will be 41 meters. Now this is answer of the second part. Now the third part is state the value which v approaches as t becomes very large. Okay, the function is v is equal to 10 into 1 minus e power minus 1 over 2 t. Now when you will make t very large, like you write it 0 0 0 0 0 0, okay, this factor will approach to 0, okay, and 1 minus 0 is 1, and 10 ones are 10, so you can check it on calculator. So we will approach to 10 when t is very large. Okay, t is very large, we will approach to 10. Now the last part is sketch the velocity time graph for the motion of the particle. So velocity time graph, it will pass through the origin, as I have, because it is passing through a fixed point O, so its origin, so it will be moving like this. Okay, and its height will be 10, because we have seen that v is maximum value of v is 10. This is v and this is t, and then it will turn to a straight line and move straight. This is the graph of the sketch of the graph, velocity time graph. So this is answer of the fourth part. So I hope so that you have understood it. So I think points are clear. If there is any point not clear, then you can talk to me on my phone number. This is my number, 0092 234078902. So this is my number, WhatsApp number. You can contact me at this number. So take care.